Namaste everyone. Today we are going to discuss the topic Compton Effect. Compton Effect was discovered by an American physicist A. H. Compton in the year 1923. He was awarded the Nobel Prize in the year 1927 for this experiment. This experiment is a very important experiment as it proves that the radiations like the light rays, gamma rays, X rays have particle nature. These rays can be explained in terms of discrete packet of energy, that is quanta, which is also known as photon. In this experiment, monochromatic X-ray beams are scattered by graphite crystal. It is observed that some scattered photons have longer wavelength. In this lecture, we are going to see what is the definition of Compton effect and Compton shift. Then we are going to see the experimental arrangement and lastly the characteristics of Compton effect. So in order to explain what is Compton effect, let us consider a graphite crystal. Okay. This graphite crystal consists of free electrons and these free electrons are assumed to be at rest. In order to explain the phenomena for simplicity, let us consider a single electron, free electrons, which is assumed to be at rest. Okay. So let us consider of X-ray photon of energy E is equals to h nu is equals to hc by lambda. When this photon is incident on the rest electron, it imparts some energy to the electron. That is, it transfers some part of its energy to the rest electron and it gets scattered by making an angle theta with the direction of incident. Okay. The rest electron gains some momentum and it gets recoiled by making an angle phi with the direction of incidence. So in general, we can say when a monochromatic X-ray beam is incident on a graphite crystal, the X-ray beam gets scattered. Now in this case, the photon has transferred some part of its energy to the electron. So the scattered photon will have less energy and therefore less frequency. As energy is directly proportional to frequency, the scattered photon will have less frequency and therefore longer wavelength. So there is a modification in the wavelength of scattered photon. So the scattered radiation consists of modified components, that is those photons which has longer wavelength than the incident ones. But there are few photons which do not impart their energy to the electrons and they have the same wavelength as that of the incident photon. So the scattered radiations also have those photons which have the same wavelength as that of the incident one. These components or these photons are called as unmodified components. So we can define Compton effect as the phenomena of splitting of monochromatic X-ray beam into two components, that is modified and unmodified by graphite crystal, is called as Compton effect. As there is increase in the wavelength of the scattered photon, the increase in the wavelength is denoted by Compton shift. It is given by delta lambda is equals to lambda prime minus lambda, where lambda prime is the modified wavelength and lambda is the unmodified wavelength. Now let us see the experimental arrangement of Compton effect. It consists of an X-ray source which emits the X-ray beam and which is allowed to pass through slits S1 and S2. This X-ray beam, after passing through slits S1 and S2, we get a well collimated beam, and this collimated beam is allowed to incident on graphite crystal. Here, the X-ray beam gets scattered in all possible directions. The beams which makes an angle theta with the direction of incidence are collected by the slit S3 and then allowed to incident on the crystal analyzer. The crystal analyzer reflects this X-ray beam and disperses it into its component wavelengths. Then these reflected beams are allowed to pass through slits S4 and S5 and then enters the ionization chamber. The ionization chamber has got gas atoms. When the reflected X-ray photons enters the ionization chamber, it collides with the gas atoms. And therefore, after collision, the gas atoms will split up to give negative electrons and positive ions. These electrons they get accelerated towards the anode and they contribute to the ionization current. This ionization current can be measured with the help of galvanometer. So, the ionization chamber measures the ionization current, and the intensity of ionization current is directly proportional to the intensity of reflected X-ray beam. Also, the different components of wavelength can be measured by rotating the ionization chamber along the circular degree scale. Also, the scattering angle can be changed by changing the position of X-ray source. So this was the experimental arrangement of Compton effect. Now let us see what are the characteristics. With the help of this experiment, we can determine two parameters, that is the intensity of reflected X-ray beam and the wavelength of the X-ray beam. So we can plot the graph between these two parameters, that is intensity of reflected X-ray beam and the wavelength for different scattering angle. Okay. So it is observed when the scattering angle theta is equals to 0, we get only one peak or one wavelength, that is lambda, which is also called as unmodified wavelength. We can observe when the scattering angle goes on increasing above 0, it is observed we get two components, that is lambda prime and lambda, where lambda prime is the modified component and lambda is unmodified component. We can observe as the theta increases, scattering angle theta increases, the Compton shift also increases. It increases from theta is equals to 0 to theta is equals to 180. From this observation, we can conclude that Compton shift depends upon the scattering angle and it is independent of the incident wavelength and the nature of scatterer. So here we have discussed what is Compton effect, Compton shift, the experimental arrangement and the characteristics of Compton effect. Thank you.